If you look up on a clear night, the sky feels like a permanent, motionless ceiling. Quiet, steady pinpricks of light in an absolute vacuum. But that stillness is an illusion. For the last 2,500 years, sky watchers have documented a recurring disruption in that quiet dark, the Lyrid meteor shower.
We are looking at a rare, perfectly dark backdrop to an event human beings have been tracking since antiquity. When the shower hits its stride, you can expect to see somewhere between 10 to 20 visible meteors crossing the sky every single hour.
The Lyrids are famous for producing what astronomers call fireballs, intensely bright, luminous flashes that move fast enough to leave lingering, smoky streaks in their wake. We are witnessing the violent, sudden incineration of ancient cosmic debris. To understand why this material is burning up tonight, we have to look back at its origin point. This photograph shows the glowing head and trailing tail of a comet streaking through the vacuum of space. The source of our meteor shower, Comet Thatcher, is exactly this kind of massive, icy snowball. Thatcher operates on a sprawling 415-year orbital cycle. The last time it swept through our inner solar system was back in 1861. Because that loop takes centuries to complete, there isn't a single human alive today who will ever see the actual comet with their own eyes. But as this solar system diagram shows, the comet is constantly falling apart as it travels. It sheds a continuous trail of rock, dust, and ice, leaving a dense wake of material directly along its orbital path. So even though the comet itself has been gone for over a century, that invisible, frozen legacy is still out there, permanently suspended in the dark. And every April, Earth's annual orbit around the Sun carries our planet straight through the middle of Thatcher's stationary debris field. We are essentially driving a planet through a swarm of heavenly hailstones at incredible speeds. As those tiny rock fragments slam into our atmosphere, they face immense air resistance. The friction is so extreme that the rock rapidly superheats, vibrating and glowing red-hot until it burns away completely. That deep space mechanical collision is exactly what we see from the ground. The friction is the fireball. To catch this collision yourself, you just need to face the northeastern sky. As this star map illustrates, the glowing streaks will all appear to radiate outward from a single origin point, a specific cluster of stars known as the constellation Lyra. Finding Lyra is easiest if you get out of the city. You need to physically relocate to an open vantage point where tall buildings and artificial lights can't block your view. Once you're set up, you have to wait. It takes a full 30 minutes for the human eye to physically acclimate to absolute darkness and pick up those fainter streaks. That means no screens. A single brief glance at your cell phone will instantly reset your pupils, and you'll have to start that 30-minute adjustment process all over again. If you can pull up a lounge chair, sit quietly in the dark, and just let your eyes adjust, the payoff is spectacular. You get a front row seat to ancient, high-speed fireballs silently streaking overhead. It turns a night of stargazing into a quiet moment of cosmic connection. You are aligning your own patience with a celestial cycle that was set in motion over 4 centuries ago.